Hello, welcome to CAD in Beam, where we train civil and structural engineers on live projects. In today's tutorial, we are going to look at how to estimate number of bars or steel in a column. So maybe you are given a column like this and you want to know the number of bars in your structure. Then there is an easier way to go about it. That's using the Excel sheet like this one here. So let me just expand it. That is based on BS 8666. I think you can see it there. So from your diagram, there are data or information you are going to collect, including the member type, bar mark type, type of and size of the bar, of the steel members, their number, their shape code, their length, and then with this data being collected here, then it will automatically calculate for you the weight. So you can see here, after getting this weight now, you can further come and generate your normal Excel sheet here with this search information. That's member, bar mark, center. Now in that, now you have this in your Excel sheet, the special Excel sheet from BS. Now you put your data into normal, and then from there now you can be able to maneuver and calculate other parameters like now the total length of your bars, number of 12-meter bars that are required of each bar size, their weight and what have you. So you can simply come and create a complete Excel sheet like that, interprets everything, and you can go further, do your summary. So if you are interested in learning on how to do all this, then this video is for you. Remember to subscribe and watch to the end so that you don't miss a piece of this part. So without wasting much time, let's get started. So once you are tasked or are given this task to do, or want to find this task to do, the first thing is to open your PDF alongside your Excel sheet. So here, this is my PDF. This is my drawing. It's not a PDF, but it's a DWG for my case, but for your case it could be a PDF. Then I just decided that we are going to use this column here. So the first thing is you just record the number, this column 2. You can just write in full, you can just say C2. And then you have the bar mark. Bar mark, you can have bar mark 02, bar mark 04. I think there was 04 somewhere. You do them in ascending order. Bar mark 04, bar mark 05, all along downward. So you can now come and select your bar mark 2 and you record the data. So like for instance, bar mark 2 for our case, you come and find you have bar mark 2. If I look at it, I'll say this is the starter bars. These starter bars are 4 in number, they are T16. Let me just enlarge it a bit. So that's the detail that will feed in your Excel sheet here. You can see the 16. So if it was D20, you would have put D20, but for my case it's D16, so I'll just highlight D16. Then write it's just a single member with each bar with 14 bar with 4 bars. Then the Excel will automatically calculate for you the total number of your bars. Then you determine the shape code of this. So this is like come here, you can see this is like a bar. However, at the lap length here, it tends to bend, but this is very insignificant in practical life. So it's just considered to be a very straight line with 90 degrees bent down here. So that one will directly lead us to bar mark, not bar, but shape code 11. Shape code 11, as you can see it here. So shape code 11 has A and B. So the length of A, the hook length is 300, while this one You can calculate now the longer length, which is the lap length, which is 18. Remember, lap length is usually calculated. Let me get my calculator. Lap length is usually calculated as 50 times diameter. So you have 50 and you are dealing with bar mark. We just put a bit 50 and we are dealing with bar mark 16. So you have 800. So this is the 800, we have it here. So this is 800. Let me just enlarge this. So you have 800 here. 800 as the lap length. So you just take that lap length and then you just come and add this foundation height, which is 1650. So we go back to our calculator, add just clear, just say 1650 plus 800 minus 50, the cover at the bottom. So you have 2400. So this 2400 is what you come and fill it. And fill it at your shape code here. You fill it here at 200. 2400, and then you have the hook length, which is 300. So that's how you fill shape 2. And then come to 4. So what's 4? 4, let's just see, bar mark 4. Bar mark 4 is here. So bar mark 4 tends to be just this bar, this the most top bars. They are starting from here all the way to there. So that's 3150. 3150 minus, you can see it's 3150, but there is this cover at the bottom of the beam. So we can say that is, in most cases, the engineer will give the specification of the cover, but for ours here, maybe at the notes besides your PDF drawing, they will be indicated the cover here. But for our case, this is a slab. We can say it's just, let's give it 25 or 20. Just give it 20. So we have 3150. 3150. Let me continue. Let me calculate it here so that we are all of us up clear. We have 3150 minus, just say 20. Yes, so that is the length. Then remember there is some hook here. There is also some hook length here on top. This is 16. You know the hook is usually 10 times the diameter of that. So that is 16 times 10, that's 160. That is 16 multiplied by 10, which is 160. So we have our, we can now come here and record. That was a shape code 11. Okay, this also was shape code 11. This was shape code 11, and it had the A distance is 160. And then we have this is 31, 31, 30. And then we have, it was 16. You can simply change all this. It was 4. Don't confuse, just be keen and everything will just look. And then when you come now to bar mark 5, I think it's the last one I'm doing, then I believe now you'll be able to do everything. So just come to the links. The links here, that is 5. Is 5 indicating the links? Yeah. So 5 is showing us the links here. It's based at 175. And there are 21 D10. So simply come to your Excel sheet, that shape code 51. I mean, this is the shape code here. This shape code 51. So we simply come here come it our shape code 51 and then come to, after getting shape code 51, you simply come, it is T20, this is 10, you have the detail, these they were 21, but they are 21 here, confirm they are 21, yeah, they are 21, you can see here, that's the specification, and then the diameter is 225 by 225, so you can work out the cover. Let's just see to get that. So you consider this cross-sectional area which is 225 by 225. So remove the cover on both sides. So you'll find that this is 225 minus 50. So you get your calculator here, which is 175. 225 minus 50, 175. So that is the length of the square length of that bar. So you just come on your Excel sheet and you record that is 175 by 175. Then you can add 100 by 100. So that's the length that you have now. So that's how you work out and collect the data using this Excel. And once you do this, it automatically gives you the weight, and actually below here it gives the total weight, and it converts those weight into ton. I think somewhere here they are indicated the weight in tons already. You can see, I just believe it is visible. Let me, yeah, I think it's visible. Yeah, so you can see here it's converted everything. So now transfer this data to your Excel here. Yes, to an Excel, leave alone this one. To this now normal Excel sheet. Consider center to center distance and also give the members the bar mark as indicated here. And then now when you come to calculate the length, it's the same thing as beam and slab. Now once you calculate your data, which is the hardest part, now you can come here and analyze. So to calculate your length, you simply say you take the number of pieces, then you multiply by the length per piece, then you put brackets, and then you convert everything into meters by dividing by 1000. If you have that formula, then you just use that formula and run it across all these cells up to this part here, and you already have it there. So you also come to bar 12 now. If now you have the total length and each length is 12 meters, then you can simply work out. So divide do division. So brackets divide by this cell, strap 112. But now remember, you have to add 1. You add plus, no, just plus 1 for a decimal point and 1 which is part of the formula. I mean this formula here. This D, not this one, but to calculate the length is usually L center to center distance plus 1. But remember, we also have some decimal points which we factor in. So that's why I think some decimal points is plus 1 for the formula, which is plus now 2. So plus 2. And then you simply click OK, and then you run your formula across all these cells, and you have your answer now. What has been left here, it is now simpler. Shape code, I think shape code you can simply copy paste here. Simply come to this and just copy paste your shape codes that are here. For instance, here I can just bring an arbitrary, let's say you had done everything, copy, come and transfer it trying to be as slow as possible so that you understand. Then come to weight in kilogram per meter. So this is calculated by this formula here, which is d squared over 162. So this one will give you the length per meter, and then when you multiply by length, you get now the total weight. So just come here and write that formula in your Excel cells. Here we will say that this one will equals to the d. D is the diameter of our bar. For instance, this d, you multiply by another d, you multiply by that cell, you can just put your brackets and then just say that's d squared over 162. Then just say enter. That's the weight of that bar per meter. Sorry. Have your formula there. Once you are done with that, I think the video is simply getting too long. Now you can just come and calculate the weight in kg. Leave your comment, remember to subscribe. And then this is C, then you simply multiply by weight per length, this length, and then you multiply by now the weight, weight per length. Like each length per meter, this is the weight you have per meter length, and this is the total length of that bar. So you simply get your total weight here. Is that way. Here you simply do the summation of this. So sum equals to the first top to the bottom. Then you have your length there. I can just redo it as the final part. This one equals to sum bracket, hold shift, go up, click on here, then go down, click on that cell, and simply click out. Oh, I think we have missed something. You simply come here, click on that. Yes, you have your bar there. So if you have any question on how to calculate something like this, and this is now the bar bending schedule that you have. You have your shape code, you can direct how to bend the bars and everything. Thank you for listening, and let's meet in another tutorial. Thank you so much. Remember to subscribe, like, comment, share with your friend if this was helpful for you.